Hello and welcome to the Edexcel Further Maths Mechanics 1 videos. This is the Impulse and Momentum 2 section, video 2.2, the Impulse Momentum Principle in Vector Form. So if you remember from your previous work, the Impulse and Momentum Principle, we are now going to extend it to use it with vectors. So we've got impulse is the force times time, and the impulse is the change in momentum. So it is the mass times the final velocity, subtract the mass times the initial velocity. The impulse and momentum are both vector quantities, and they both have units, newtons, seconds. We're going to carry on using the same methods as before, but now we're going to be working with velocity and impulse in vector form. So we're going to start with an example where we have a ball of mass 0.5 kilograms is stationary when it's struck with an impulse of I plus 5j. If you remember, the formula for impulse is the final velocity subtract the initial velocity. In this particular case, the initial velocity is 0 because it is stationary. So we're going to have that the impulse I plus 5j is equal to 0.5 times the final velocity. So if we divide both sides by 0.5, we get that the final velocity is 2I plus 10j. Now that we have the final velocity, we can use it to find the new speed and direction of travel. So we remember from the previous slide that the final velocity is 2I plus 10j, and the speed is just the magnitude of this vector. So that is 2 squared plus 10 squared square rooted. So the final speed is 10.2 meters per second. Now, as I mentioned previously, it's good to draw yourself a little diagram so that you can have an idea of what kind of angle you are expecting. And we can see here that the angle that we're making with the I direction is positive. So tan theta is going to be 10 over 2. Which leaves us with an angle of 78.7 degrees, which fits with our diagram. Okay, so we're going to move on and look at a second example now. We've got a ball of mass 3 kilograms travelling across a smooth surface. It's got initial velocity 2I plus j, and then it gets struck with an impulse of 3I minus 6j. So again, let's write down our impulse formula. Mass times the final velocity minus mass times the initial velocity, the change in momentum. So we have 3I minus 6j, and that is equal to 3 times the final velocity minus 3 times the initial velocity, 2I plus j. So if we multiply out this bracket, we're going to get 3v minus 6I plus 3j. Rearranging, 3 times our final velocity is going to be 9I minus 3j. So our final velocity is 3I minus j. Now what we're going to do is look at the kinetic energy gained by the ball during the impact. So again, from previous work, we should know that the change in kinetic energy is the final kinetic energy, which is a half mv squared, minus the initial kinetic energy. Here we have the speed, so we're going to need to find the speed, the initial speed and the final speed. So the initial speed is going to be 2 squared plus 1, so that is 5, and the final speed is going to be 3 squared plus minus 1 squared, so that is 10. I'm leaving them squared because that's how I'm going to need to use them in the formula anyway. So if we now substitute those in, we've got our change in kinetic energy is a half times our mass times 10, subtract a half times our mass times 5, which means our gain in kinetic energy is 7.5 joules. It's a gain because it is a positive value. That's the end of this video on the impulse momentum principle in vector form and this section on impulse and momentum too.